Okay, welcome to multiplying radicals. So let's go ahead and dive right in. We have some properties of radicals that we need to take a look at. Assuming that A and B represent non-negative numbers, non-negative numbers, which means they're just not negative, right? Non-negative numbers, we have the following properties of radicals that are going to be useful. So square roots undo squares. I want to add another one to this. Remember when we talked about radicals a while back, we said that the square root of a squared can also be written that way. Okay. Square roots undo squares. So that is also a. Off to the side over here, let's do a couple quick examples. Let's say I, for instance, gave you the square root of 49, and I wanted you to square that. According to what we just wrote down over here, that should be 49. Let's think about why that works. Square root of 49 is 7, and 7 squared is 49. Square roots and squares undo each other. They're inverse operations. Okay? Same thing works if it's not a super friendly number. 49 is a perfect square, so we could see it very easily, but we need to remember that when I do the square root of 5 times the square root of 5, that's going to be square root of 5 squared, which is also 5. Okay? Square is square root. They undo each other. Square roots and squares. Okay, same property is valid for index n. Like if I had a cube root or a fourth root, as soon as the index matches the power, there's an inverse operation, and we get the radicand simplifying. Let's just say it this way. The nth root of a to the n is a. We also have these properties. Square root of ab is the square root of a times the square root of b, or I can reverse it and use it the other way. Square root of a times the square root of b is the square root of ab. Or we have the fraction rule for radicals. Square root of a over b, I can apply that radical to the numerator and to the denominator separately. So for instance, the square root of 9 over 4 would be the square root of 9, which is 3, over the square root of 4, which is 2. It's because of the way fractions multiply. And the same is true for other indexes. Okay, now, special note. If we try to use this rule up here, square root of a times the square root of b equals the square root of ab. If we try to do that when both of the radicands are negative, it doesn't work. Okay? Does not work. So when you're working with radicals that involve square roots of negative numbers, rewrite them in terms of I first, and then work on them. We're going to need to use the distributive property when we're multiplying radical expressions, and we use some of the techniques we learned with polynomials. So let's go to work on some of these examples. Now, there's a lot of examples in your note packet. We're not going to do them all. We're going to do 1 and 2. So let's start here. Let's see. That's the square root of 60 because 10 times 6 is 60, right? So I can write it as 10 times 6, or I can write it as the square root of 60. And then we're going to simplify that radical. It says multiply and simplify. So now we're to the simplifying. So notice in that 60, I do have some simplifying that's going to go on because I at least have a 2 and a 2, right? So we'll just do our technique. 2 goes into 60 and leaves 30. 2 goes into 30 and leaves 15. 15 is 3 times 5. So I don't actually have any perfect square factors other than the 2 times 2. All right. I've got my pair of 2's. So a 2 comes out. 3 times 5 is 15. We've got the 15 underneath. Hopefully we're getting to be really pro at working with radicals. We have 2 times the square root of 15 for our answer. And next one. So here's how we're going to work with this one. Okay, look at the signs. We have a negative times a negative. Negative times negative. Oh, see, this is multiplication. Negative 2 times the square root of 12. And we can switch the order that we multiply. Negative times negative is going to be a positive. It's the first thing I'm going to do. Then I'm going to switch them around and do this kind of multiplying. Okay? So what's the square root of 3 times the square root of 12? 3 times 12 is 36, so it's 2 times the square root of 36. See how that 2 is just hanging out in front? Okay, now square root of 36 is 6. So we have 2 times 6, final answer, 12. Okay. And if we did it on the calculator, we could check that answer and make sure we get a 12. Be careful where you place the parentheses, right? Okay, example 3. And then we're going to skip example 4. And I'm going to skip, I'm going to do the other 2. So I'm going to skip example 4, but we're going to do the other 3. So first thing, remember when you have a square root of a negative, the first thing is write it in terms of I. So notice the negative under the radical. First thing we're going to do is pull the negative out as an I. So I have 2I radical 5. Same thing here. First thing I'm going to do before anything else, I'm going to pull the negative out as an I. And now I'm going to do some multiplying. Okay? So we're going to switch the order. Negative times positive is a negative. 2 times 4 is 8. I times I is I squared. Square root of 5 times the square root of 10 is the square root of 50, because 5 times 10 is 50. Then we're going to use the fact that I squared is negative 1. And we're going to simplify that square root of 50. Now, what do I see in that 50? I see a 25, which is 5 times 5. Okay, so a pair of 5s. So the square root of 50 is going to simplify to 5 radical 2. 5 comes out, 2 stays under. Notice what we have. Negative times negative is a positive. 8 times 1 is still 8. 8 times 5 is 40. We have 40 times the square root of 2. I'm done. Okay. We're skipping example 4. We're going to go to example 5. Now, what I want you to focus on, look at the structure of what we're multiplying. See, there's multiplication going on. See those parentheses? There's also a plus sign inside the parentheses. So we're going to use the, distributive property. Okay? So we're going to distribute. We're going to take 6 radical 3 times 2 radical 2 plus, remember how the distributive property works, then we do plus. Okay, next we're going to do 6 radical 3 times 5 radical 3. So we're going to do plus 6 radical 3 times 5 radical 3, or square root 3. 6 square root 3 times 5 square root 3. Okay, now this is going to be like what we did, a little bit like what we did with polynomials. So we're going to multiply the 6 times the 2 and get 12. What's square root 3 times square root 2? It's square root 6. Plus, what's 6 times 5? Think of those as being the coefficients of the radical. It's in front. 6 times 5 is 30. What's square root 3 times square root 3? It's square root 9, but it's also 3. So we'll have 12 times the square root of 6 plus 90. 30 times 3 is 90. Or I could write 90 plus 12 square roots is 6. It doesn't matter which order we write them in. And we're done. Okay, now, example 6. This is like doing x times y to the second power. You do x to the second power, you do y to the second power. Look at the structure of what you're working with. We have 4 times the square root of 6. It's like doing x times y and then squaring it. You have square the 4, square the square root of 6. It's not the only way to do it. You could write it out as 4 square root 6 times 4 square root 6. 4 times the 4 turns into a 16. Square root 6 times the square root 6 turns into a 6. 16 times 6 is 96. Done. Okay, we're going to flip to the next page where we're only going to do example 10 and example 12. So I'm skipping all the others at this point in time. Not going to X through them, just going to skip them. Maybe your teacher wants to do something with them. But I'm just going to do example 10 and example 12. 10, 12. So we're doing example 10, and then we'll do example 12. So notice what we have. I'm going to move this over just a little bit. So I have just a little bit more room like you have on your paper. You got a little more room, right? So example 10. Notice what I have. This is like doing a binomial times a binomial. See that plus sign? See that minus sign? It's like multiplying polynomials. So I'm going to show you with the distributive property. And then I'll also show you with the box method. So if I use the distributing method, I do square root 3 times square root 3. That's going to get me a 3. I'm going to do square root 3 times square root 2. Well, that's a minus, right? That's square root 6. Then I'm going to do square root 2 times square root 3. That's going to be a plus square root 6. I've run out of room, so I'm just going to go down a little bit. Minus, because a positive times a negative is negative, square root 2 times square root 2 is 2, because it's the square root of 4, right? Square root 2 times square root 2. Think about what it is. It's a 2. So what do I have? I have the square root 6's wiping each other out because one's negative, one's positive. I have 3 take away 2. My answer is 1. Now let me show that you can do this with the box method as well. So you've got square root 3 plus square root 2. So we'll have 2 columns in our box. And then I have 2 rows. I have square root 3 and negative square root 2. Don't forget the negative. Okay, what's square root 3 times square root 3? It's 3. What's square root 3 times square root 2? Square root 6. What's square root 3 times negative square root 2? Positive times negative is negative, and that's square root of 6. Negative square root of 6. Negative root 2 times root 2. It's going to be negative, but root 2 times root 2. Square root of 2 squared is 2. Okay, look at what happens when we add those together. Radical 6 and the negative radical 6 zero out. And 3 take away 2 is 1, so I get the same thing. So you can do these with the box. Okay, we're going to look at example 12, and then we are finished. So let's look at example 12. All right, example 12. I'm going to move this over again. So I have a little more room, just like you do on the right side of your paper. You got more room. Okay, so I'm going to do, this is not the only way to do it, but this is the way I'm going to show. Square root 5 plus 3 times square root 5 plus 3. You cannot just distribute the square. That doesn't work when you have an addition sign. You can't just distribute the exponent. All right. So what we have is square root 5 plus 3 times square root 5 plus 3. So I'm going to use the distributing method, or you can use the box. Square root 5 times square root 5 is, yep, you guessed it, it's 5. Maybe I'll do that in red. Square root 5 times square root 5 is 5. Let me do the next one in green. Square root 5 times 3 is 3 square root 5. It's like doing 3x. 3 times x. 3 doesn't get to go underneath the radical. Okay, next one. Okay, I'm going to now move to the 3 and let it multiply. So there's another 3 times radical 5. Okay, and then lastly, we're going to do 3 times 3, which is 9. So we get a plus 9 back here. Okay, let's put it all together. 5 plus 9 is 14, so those are like terms. 3 radical 5 plus 3 radical 5 is 6 radical 5, and we are finished. Okay, good luck with the assignment for 2.3.